Hey guys, I'm Mr. C. Welcome to our first day of summer math. Today's focus will be on equations, inequalities, and formulas. Now, this is the warm-up that we did in class, right? What is the difference between an equation and an equality, right? An equation says two things are equal to each other, whereas inequality may say one thing is greater than the other, or in some cases greater than or equal to. Then a couple of equations that you guys had no problem solving in class, right? You just got the goal here, getting that x all by itself, right? So you subtract the 12 from both sides, right? So we get negative 3x equals 6 minus 12, which I guess would end up being negative 6. The final step, divide by negative 3 to get that x all by itself. And there we have x equals 2. Okay, so this one here, solve the inequality, same exact stuff, right? Except this symbol is different. Now, what you guys may remember from your Algebra 1 class, you may not. Basically, we're solving this the exact same way, right? Subtracting that 12 from both sides, right? Except for one big difference. And that big difference is that when we divide by negative 3, what we have to do when you divide by negative 3, or divide by any negative, right, what you got to do is you got to switch that sign. And so anyway, that's the one way you might get hung up on that problem, right? Remember, if you multiply or divide by a negative, you got to switch the sign. And then finally, explain why x equals 2 is not a solution. Well, let's just plug it in and see what we got. So 3 times 2 minus 5, let's see, is greater than 4. Let's see if this ends up being a true statement. 6, sorry, my tablet gave me a little trouble there. 6 minus 5, is that greater than 4? No, that is positive 1, which we know is not greater than 4. That is not a true statement. And so that is why 2 is not a solution. All right, so let's get into our quick notes for the day, right? This is some review of how you solve an equation, right? Basically, the goal is to get x all by itself, right? And how do you undo a plus 5? Well, you minus 5. And if you do it to one side, you got to do it to the other side of the equation as well. Two-step equations, basically the idea is like you are unraveling the variable, getting that variable all by itself, and you kind of do, I guess what we say is reverse order of operations, right, to get that variable all by itself. So first you get rid of that plus 5 by subtracting 5, and then you get rid of the multiplied by 2 by dividing by 2. Right. So anyway, that's just a basic example, basic review of simple one-step, two-step equations that you guys remember very, very well from Algebra 1. Okay, now this is actually an official MCAS question that came out, I think probably, I don't know, at some point. Now, what this is they give you an equation, right? And then they ask Marvin's steps here. I'll just read the problem. Marvin created a table showing each step he used to solve the equation. The table also showed the correct explanation for each step. Okay, so which of the tables shows the correct explanation for each step? Okay, so it looks like all of these are actually the exact same steps, right? So the steps are not different, right? It's just what are we doing in each case here, right? So, so first of all, the first thing it looks like he did here was he distributed the 4. Now I know you could have divided both sides by 4, but that's not what Marvin did, and Marvin solved this correctly. So first thing he did was he distributed the 4. So let's see. Did he multiply both sides by 4? No, I wouldn't say that. Did he use the distributive property? Yep, he did do that. He added both. He used the distributive property. Yep, he did do that. He added 4 to both sides. Okay, so first of all, we know A and D have to be wrong because the first step, he's distributing, he's not adding, he's not multiplying. Well, he's not multiplying both sides, I guess I should say, which is why he's wrong. Okay, so now it's a 2-horse race between B and C. So next, how did he get rid of that 20? He subtracted 20. Here he divided 20. He did not divide 20, he subtracted. So I get a feeling B is going to be right, but let's just finish the job here. Finally, he's going to divide both sides by 4, which is exactly what it says he does. which is why B is the correct answer. All right, now this is another MCAS question, right? So questions where you have to solve equations or solve for variables. They come in different shapes and sizes, but it's all just about balancing the equation and getting the variable you're looking for all by itself. Even if you're not solving for a number, instead you're just solving for a variable expression like we are in this case. So anyway, the equation represents the ideal gas law where T is the temperature, right? Which equation has been correctly rearranged to solve for T. So basically getting T all by itself, right? I rewrote the equation here so we could kind of do it together step by step. Now, actually here, your goal of getting T all by itself, both N and R are both being multiplied, right? And how do you undo multiplication? Well, you undo multiplication with division, right? So that's what I'm going to do, right? Both R and N are canceled out. This is what we're left with. Let's see if that is one of our choices. Yes, it is. That is why D is the correct answer. All right, the next thing we did in class, we talked about inequalities, right? I don't know how you remember this. Some people like to say, hey, the alligator's eating the bigger number, right? Some people like to say, oh, hey, or I should say the bigger quantity. Some people like to say, oh, it's pointing at the smaller quantity. Well, hey, whatever works for you, it works for you, right? So here we've got examples of the number line over to the left here, which is how you would represent your inequalities if you were to graph them. And so x equals -2 means that the x is just the dot is on the -2. Actually, truth be told, looks like we got a little bit of a typo here, but yeah, it should actually be there, -2. Sorry about that, you guys. But then if x is greater, it's all the numbers that are greater or equal to -2, right? If x is less than -2, less than or equal to, it's all the numbers that are less than, like -3, -4, and so forth. Now, the difference between greater than and equal and just greater than is greater than and equal has a filled in circle, whereas just greater than has an open circle, meaning that right here, x equals -2 would be a solution to the top graph, but x equals -2 would not be a solution to the bottom graph. And also you may have an interval like you see here to the right? The x is between, it is greater than or equal to -1, which is why -1 is filled in, but it also has to be less than 2. So it could not also be equal to 2, which is why that is open. Right, so anyway, those are your inequality symbols. And now solving inequalities. Now what you guys will see, much like we did with our warm-up, you guys, it basically is just a review of the warm-up that we did. Solving inequalities is basically the exact same thing as solving equations, with one other thing that you need to remember is that if you do multiply or divide by a negative number, you gotta flip the sign. All right, so just remember that, and you're gonna be in great shape. Also, with these standardized tests that you guys kind of always tend to take, right? If you don't flip the sign, there's probably going to be a trap answer that just tests, did you remember to flip the sign? Just be on the lookout for that. Make sure you flip the sign if you multiply or divide by a negative. Okay, now this is an absolute value inequality. Now the thing with absolute values is you end up having, typically you end up having two solutions. I mean, I guess if the absolute value was equal to 0, you would have only one solution. And if the absolute value was I don't know, a negative number, you would have 0 solutions because an absolute value cannot be negative, right? But that usually doesn't, usually there's two solutions because usually they want to see you do some math. And so they'll make the absolute value greater, a number greater than 0. So in this case, it's an absolute value inequality, right? So what we have here is we will break this equation into two equations, right? So one equation, which is the opposite, which is the obvious, excuse me, is that 4 minus 2x, right, would be just greater than 6, right? That's kind of the obvious thing, right? And what would make that work? Well, hey, if 4 minus 2x was 7, 8, 9, 10, 11, a million, any of those would work, right? Because any of those things, this quantity is greater than 6, right? Now, here's the other thing. What if this quantity ended up being like -7, right? Would that be a true statement? Would the absolute value of -7 be greater than 6? It would, because the absolute value of -7, right, would be 7, which would be greater than 6. So what we need here is then what we're saying, right, is that whatever is in here, if this was negative, right, would have to be less than -6. So things that would work. -7 would work. -8 would work. -100 would work, because all of these, -7, the absolute value of that is 7, right? Which is greater than 6, right? What wouldn't work? Oh, hey, if it was like, I don't know, if this was -2, no, that wouldn't work, because the absolute value of -2 would be +2, which would not be greater than 6. So what does that mean? What does that actually mean? Well, basically, it's kind of similar to the rule you just learned, right? When you were dealing with an inequality, right? Remember when you multiply or divide by a negative, right? You flip the sign. Same thing applies for absolute value inequality. So all I'm going to do is I'm going to copy this quantity down, but I'm going to recognize that this has to be, watch this, what I do when I go negative, watch what happens, I flip the sign. Okay, now if you're wondering why the heck did I do that, why can I get away with that, right? Remember, things that will work for this, right? -7, -8, -100, it's got to be less than -6 for the absolute value to be greater than 6. Okay, so if you got everything I said, great. If all you remember is, hey, when you go negative, flip the sign, great too. Okay, so anyway, all I'm going to do here is I'm going to solve this like I would solve any other equation, right? I, excuse me, subtract 4. So -2x is going to be 6 minus 4 is 2, right? And just to be clear, I subtracted -4, which is how, excuse me, subtracted 4, which is how I did that. Now I'm going to divide by -2, and I'm showing this step. The reason is because something happens when you divide by a negative. You guys know what it is by now, right? I gotta flip the sign, right? So that ends up being -1, I believe. And then over here, right, I do the exact same steps, right? Subtract 4 from both sides. -2x is less than, oh, there's an x there. Less than, not less than or equal, just, let me just write that over. -2x is less than -10, right? And remember, we're about to divide by a negative, -2. And when you do that, you know what you got to do. You got to switch that sign. So there's a lot of sign flipping going on here. All right, so this is our two solutions, I guess, to say, which really just tells us, you know, it's not over until I fit it to a number line. So what do I going to have? So x has to be less than -1. Okay, x has to be less than -1. Okay, so this looks like that piece satisfied. And then x could also be greater than 5, right? Which means this piece here is satisfied, right? That is why C is the correct answer. Okay, so I know that was kind of a long-winded explanation, but those are the steps. There was a lot of places where you could have made mistakes, right? And the big thing there is making sure absolute value inequality, right? You make it into two inequalities, not two equations, two inequalities, solve for both inequalities. And just remember, when you multiply or divide by a negative, right, you flip the sign. Okay, now if I ask you, would you rather do math with numbers or letters? Everybody's going to have the same answer. Numbers are better than letters all day long. Now, what I want to talk to you about here is stuff that people consider to be geometry, because it is, right? But really, all you're doing is you're trading numbers for letters, and you're doing a little algebra, and I'm talking about using formulas. What I have here, all your formulas, official formulas from the official MCAS formula sheet, right? Area, volume, surface area, all they are just formulas. All formulas are opportunities for you to trade numbers for letters, and we're going to do just that with an official MCAS question. This was number 26 on, I don't know, the demonstration MCAS, or maybe it was last year's MCAS. I don't really know, but official MCAS question right here. The right circular cylinder, an oblique circular cylinder, and some of their dimensions are shown on this diagram. Okay, and then they're asking what is true. Is the volume of S equal to T? Is it less than T? Is the volume of S greater than the volume of T? Or is there not enough information to figure this out? Well, here's the deal. Excuse me. We've got some cylinders here, right? And so we will use the cylinder formula. Okay. And the truth is, if I didn't have the formula, I don't know if I'd be able to solve this problem, but we're saying they're both cylinders. And so now we're going to try to solve this problem. Okay. So, so first of all, the volume here is going to be equal to pi times r squared. Okay, so if this is 3, that's going to be 1.5 squared. The height in both cases is 7. Okay, so over here, the volume is going to be pi times 1.5 squared times that height, which is 7. Okay, so, well, I could do this math, right? Sure, I could. I could crunch all the numbers, except for the fact I got the exact same thing here as I do here. So that is why I am going to say that these two things are equal to each other, and that is my answer. Okay, if you want to go crazy and, you know, arguably waste your time and actually crunch the numbers, you are welcome to, but you don't need to because they're the same thing. Okay, now sometimes on the MCAS, you may see a question that you don't know what to answer. You've never even seen this before. And the truth is, many of you will not even see this until Algebra 2. Some of you guys have taken Algebra 2, so you know exactly what I'm talking about. All right, and when this happens, right, and it will, no matter how good your math teacher is, no matter how many advanced math classes you have taken, you will inevitably see something on one of these standardized tests that you are unfamiliar with, right? So, you know what we could do? We could cry about it, or we could just do the best that we can. So, so something you may or may not know, right? The cubed root of t, right? Now just a little something, right? The cubed root of t is also t to the 1/3 power. Okay, now, anyway, I could talk all day about this, right? Also, the square root of x, right? Just use a different variable, could also be written as x to the 1/2 power. And if you really want to get wild, if you had like, I guess if we said y to the 5th power, the third root of that you could write as y to the 5/3 power. Okay, anyway. Maybe you learned that in math class. Maybe you didn't. Okay, but what the heck? So which of the following is equivalent to the expression? Select 3 equivalent expressions. Okay. All right. So this is a challenge. I mean, there's no question about it. But now that I have told you that, right? Right. And you could just say, well, where the heck is the 2 coming from, right? I mean, that could be a good question here. But if your exponent is 1, right, because it's just going to be the 4th power, right, and the third root, right, so what times itself, you know, 3 times would get you t, right? So A is obviously one of the right answers. Okay, now let's talk about our exponent rules here. Well, 1/3 is not going to be the same as 2/3, so that can't be true. 1/3 is not the same as 3/2, so that's not true, right? So now it just becomes a matter of using our exponent rules. Now, 1/3 over 2/3, I guess since I know that I'm subtracting my exponents, that would be to the negative 1/3 power, right? Which wouldn't be true. Here, 2/3 minus 1/3, right, is going to be t to the 1/3, which is the same as this. Right? Oh, sorry, 1/3. And then here you've got, so just to be clear, what I'm doing here is I'm subtracting the exponents, right? So here I did 1/3 minus 2/3. That's how I got my negative 1/3, right? Here I did 2/3 minus 1/3, which got me 1/3. And here, if I go 4/3, and then if it's just t to the 1st power, right, it would be minus 3/3. And so that would also be 1/3, right? Okay. Why did I go through all of that, right? Because I wanted you to understand that even if you did not know that these two things are equal to each other, right? But we're looking for 3 equivalent expressions, right? Just using your exponent rule, specifically that when you divide, you subtract the exponent. So the thing that you learned in Algebra 1, right, where you learned that x to the 5th divided by x squared, you subtract those exponents, and that's x to the 3rd. That thing that you learned, that thing that all of you know, was the key to solving this problem, right? You may have never in your lifetime seen a fractional exponent. You may not even have known that it is possible to have a fractional exponent, right? And you didn't need to know in order to solve this problem, because if you know that dividing, you subtract the exponents of like bases. If you knew that basic exponent rule, you would have known that A, E, and D are 3 equivalent expressions, and that's all you would have had to know to solve that problem. I'm not saying it's easy, I'm just saying it's possible. All right, now for the IXL preview, this will be your homework, along with a couple of MCAS questions that we've selected for you. But here, this is just letting you know what you're gonna be asked to do right here. You know, just graph. X is less than or equal to 440, so I guess I would color it in because it's equal to, and I would just have the arrow go this way. That's all you're gonna have to do, right? Next one will ask you to which of the following solutions, which are solutions to the inequality. So it could be all of them are right. It could be just one of them are right. Basically, if you plug that value in for B, will you get a true statement? And if you do, you will check off that answer. Okay, now we're solving inequalities just like you guys, just like we have done together, you know, throughout this lesson, right? So I don't need to do that again, unless of course you want me to, and if you do, just let me know. You guys know you can email me or Miss McNally. And here, right, these ones, I don't think we did a problem exactly like this. Is kind of a combined inequality. It tends to be like an interval between 2 numbers. So I will do this out, right? And it's just, how do I get J by itself? Well, what you got to do is you got to add 8. And if you're going to add 8, you got to add 8 everywhere, right? So here, this ends up being 0. This ends up being -3. Okay, so how would I write that in my number line? Well, what I would have is I would have, let's say this is 0, right? Let's say this is -3, right? So you get -2, -1 in there, right? -3 is a closed circle, right? 0 is an open circle because it can't equal exactly 0. And then I color in the stuff in between. That's how you would answer that question on your IXL, or anywhere you see a question like this, right? And then here, an absolute value inequality, where you have a couple of steps, right? We didn't do one exactly like this, so I wanted to take this opportunity to do this. I'm going to add 9 to both sides, right? And I think that would get me t minus 5. The absolute value of t minus 5 is greater than, what is that, 46, I believe, right? 46? Yeah, 46. I guess it would be 46. Okay, and then what am I going to do here is I am going to make this 2 equations. T minus 5, right, is greater than or equal to 46, right? That is kind of the obvious one, right? But then remember, the other one is I have to go negative, so that t minus 5 could also be less than or equal to -46, right? And here, all I'm doing is adding that 5 to both sides, right? So t is greater than or equal to, I guess this would be 51. And over here, t is less than or equal to -41, right? Oh, -41. Sorry about my tablet there. Give me a little trouble, you guys. But anyway, and then you would you know, make it a compound inequality, right? So I guess that this is the form they want. So let's see. So this would be, you know, if I were to draw this on a number line, right? So you got your 51, you got your -41, right? And so you've got t is greater than or equal to this, right? And t is less than or equal to this. Okay, and the way you would write this, this would not be an interval statement, right? Like you saw over here, right? It would be one of these where you would say x is, well, I guess we would say t is greater than 51, or t is less than or equal to negative 41. Sorry about the tablet, my handwriting, you guys. Doing the best I can. All right, anyway, that's the hardest thing you're going to do on your IXL. And then for your homework, right, we've got 3, just review your distributive property. This is something that we did not do with you, but basically, right, you just distribute that, that negative 5x, right? Inequalities, right, we did a lot of these today, right? So we're not going to bore you again. Just remember, if you divide by a negative number, make sure you flip the sign. But as you saw in our last 2 problems, if you don't divide by a negative, right, you don't have to flip the sign. And then here, just graphing an inequality. We're going to focus a little more on this in a lesson down the road, right? But it's definitely worth reviewing. Okay, so again, hey, you guys, I'm Mr. C. This brings us to the end of our first lesson, right? I hope you guys enjoyed the video, and we'll look forward to seeing you on our next class tomorrow.